Sure.
Can you go back to that slide? I did not get the names.
Oh, yeah, there we go.
Thank you.
Can I go?
Give me a sec.
Okay.
All right, so this is your project B. Have you presented project A?
Yes, we presented the
Okay,
Hadoop project yesterday, Monday.
Here, I have that thing.
Sorry, 1 second.
All right, guys, go ahead and get started. It's recording, so go ahead.
All right, I'm back. Sorry about that.
We have to go ahead.
Okay, so our project was configuring Nginx to be an HTTP load balancer. And I'll let Steve give you the overview here.
So what is Nginx? It's a free and open source web service software. It's able to function as a web browser, reverse proxy, load balancer, and an HTTP cache. It's the most popular web server, runs about 419 million web servers, which is just over a third of the internet. And it was created in 2004. So why would you use Nginx? It's able to handle about 10,000 connections at the same time while maintaining a low memory footprint. It's asynchronous, non-blocking, and it's also an event-driven architecture. It's more efficient than Apache, so it can handle just about 4 times the connection that Apache can on the same exact hardware. However, it's less flexible than Apache, because its configurations are harder to change. Also, it has a paid version, which you can get additional features with.
Just to expand on Nginx and Apache. So Apache was released in 1995. Nginx came out in 2004. Apache is also a web service, but it allows directory level configuration with HT access, and it gained popularity initially because of the dynamic module system it had. Nginx does not allow directory level configuration, which actually gives it an edge in performance, like impactful enough that people switch to Nginx. And then from Nginx modules, they need to be enabled during build time, so it takes a lot more for the person running it and to do it properly. So like it's more technical prowess. And post installation modules are even more complicated, but nonetheless, it's still more efficient, except in the case of retail hosting providers. It does not shine as well in shared environments like Apache does due to those restrictions.
All right. And then, so what we're going to do today is configure Nginx to be an HTTP load balancer. And that will, that's going to break up incoming connections into multiple backend servers. Typically, when you set this up, you would have those web servers here, as you can see on the right on this graphic. They would all connect to the same database, so you would have that like shared information pool, and you would typically also have these web servers all mirrored to each other through. You'd probably have a master site somewhere that would update it every so often. And then when you connect to the load balancer, it has several algorithms that could take you to these web servers. The default one is round robin, which means it will just cycle through any of the available backend web servers. You have sticky, so that would make it based on the client connecting. It would take them to the same web server every time, then it picks them at random, barring some other configurations you can do. Or you can do least connections, which will take you to the web server that has the least amount of active connections at one time. Our setup today is going to have 3 servers. We're going to have the load balancing server and 2 backend web servers. And we're going to take one offline. We're going to designate one as a backup. take the main one offline and show that it will still run. Here's the installation procedure. It's very straightforward. All we had to do was sudo apt install -y nginx. We had to update the hosts in the load balancing server to give it the IP addresses of the backend servers, and then on each machine we went and updated the host name, which is really just for convenience. And then on the load balancing server, that's where you do your setup, which I'll show, the configuration. You list the backend server addresses in there, and then you will set up a reverse proxy. So that load balancing server is the single point of access for your entire network. And then there's some additional configurations, like we said. You can designate an upstream algorithm. Like I said, round robin is the default. You can designate a server as a backup, which I'll demonstrate. You can set a max wait time before calling on the backups. You can also limit the bandwidth and attempts per second per connection. And you can also take a server off fairly easily. But any of these changes on the basic Nginx requires the service to be restarted, which might not make it ideal for larger companies. That's why they go for the paid version that would allow you to change this while it's running. So just a couple sources and then time for the demo. All right. So I have it all set up here. I'm logging into the load balancing server. Here is our configuration on the load balancer. You can see here we have the, this is the upstream, and we called it web backend. We set a zone for it. That can be used when you're limiting bandwidth or attempts per second. I ended up not doing that, but just in the simplest configuration, you can set what servers are on the back end, which are these two up here, Ubuntu Nginx 1 and Ubuntu Nginx 2. Then we put it on the HTTP port 80, and here we set up the reverse zone. So when you attempt to connect to the load balancing server's IP address, it will cycle through those backend servers. So here's a demonstration. Right now this is the IP address for the load balancer, and every time you go to the page, it'll take you to one of the backend servers, and that can be seen here. Slow. I had this pulled up, sorry. You can see here's the index file for that server. I just wrote two simple web pages on both of these, and I just wrote this down here to indicate which server you were on. So this is server 1, and there's one on the other one for server 2. And I can change this, of course. There you go, it updates. And now for the last part of the demonstration, I'm going to take one of the servers offline. So I'm setting the second server to go down. That requires you to restart Nginx. So now it will only connect to the first server. And that's about it. Any questions?
Nice job, very nice job. What a very simple explanation of load balancers. Really good. Guys, do you have any questions for this group?
I don't have any, at least.
Nope. Do you guys know how much faster this is than, say, what is the, let's say, Apache, or you can have several servers behind the load balancer, correct? Many.
Yeah, you can. I think as many as you would want, and you can set them as like backups. The thing I had read to answer your first question was they say on the same hardware, Nginx can usually handle about 4 times the amount of connections at a time as Apache could.
Okay.
Nginx was the first web server, to my knowledge, that solved what they call the 10K user problem, when you have
10,000 users.
10,000 simultaneous user connections.
Do you guys know if cloud services like AWS and the other ones, if they use this, or do they use their own proprietary thing? Okay.
So I know Google has their own web server that they developed. I couldn't find anything on Amazon. I think it's Nginx for Amazon.
Yeah, they have it integrated. They use the Plus version, which is the paid version, obviously.
Yeah, most.
So whenever you guys go to a lot of things online, basically, most because everyone's in the cloud, right? So most likely you're actually going to an Nginx type of thing that sends you to the appropriate web server.
And it really blew up in popularity in the last 2 or 3 years. If you saw on the chart there.
I have another question. So if you do, the load balancer is Nginx, right? But the web servers behind, do they also need to be Nginx, or can they be Apache servers, Windows servers?
I'm pretty sure they can be whatever.
Yeah, you can run Apache and Nginx together as well if you're up for just configuring it as such.
But what would be, I guess it would depend on several things, but what would be the recommended thing? To use Nginx as the load balancer and also behind the scenes as the web servers? Or it doesn't really matter, because Apache,
I would say the only benefit of Apache would be you can change the configuration of the server while it's running, because like you have to restart it on the free version. At least you have to restart it every time you make a change.
Yeah.
Whereas to my understanding, you can put one of these servers down without having to restart it on Apache.
Yeah, which makes it a lot easier for configuring like additional backend servers. So if you have Nginx being the main that is configured to pass the pool of servers, and then you have Apache set up backend, you can ask it to handle a lot of the different servers to alleviate some blocking that happens.
Okay, so assuming you're doing TCP connections, right? So that's a 3-way handshake. So you initialize the communication to Nginx. Nginx pretty much just changes the IP and forwards that to the corresponding server, and then that server takes over the TCP 3-way handshake, and then from there you're connected to that server, right? Probably like that. All right. Good. What else? Yeah, that makes sense. Excellent job, guys. All right. If there's no other questions for this group, can we move to the next one, please?
Hillary and I want to go next.
Okay, great. So just put up your names there, and then we'll get started.
I'm gonna demonstrate the Hadoop one, and then Hillary's gonna do Project B.
Okay.
It's Maite Cardona and Hillary Baker.
Hold on. Just the two of you?
Yes.
Okay. All right. So I got your names. Please go ahead and get started.
Can you guys see my screen?
Yes.
Yes.
Okay. I already have slave 1 all ready to go. So I'm just gonna go ahead and go to the master one. I'm gonna go to the user local where Hadoop is at. My VMs are really slow for some reason, so this is gonna take some time. Okay. And then from there, I'm just gonna give the directory for my streaming jar. And then since I already did like some, I'm gonna put output 2. I'm gonna click enter. This is taking a while. There it is. All right, so it gave me the output directory right here, and I know that it worked because it gave me map 100% and then reduce 100%. Let me look for that. It's right here. So I'm gonna go to where the output directory is at. I can just do this one right here. Come on. Again, I don't know why my VMs are so slow. Oh, there it is. So it gave all the words. And then if we go right here to the web page, I'm gonna hit refresh. And then we should see the output 2 right here. All righty.
Are you just waiting for it to refresh? Is that what it is?
Yeah, I don't know why it's so
It's
slow.
okay. I mean, you demoed in the interest of, time for today.
Okay.
It's great.
Yeah, and I have the other
we saw-
ones that I did here, if anything, so we know that it works.
Oh,
Yeah.
right. Yeah, we
Okay.
saw it. Yeah. So, sorry, just, because we have
Okay.
limited time.
Yeah, that was a big struggle
The
for
break.
us, the slow VMs, but we did it.
Yeah, and I wanted to do it with another slave, but again, my VMs were very slow that I doing it with the master and the slave one.
Yeah.
No, good job. Good job.
All right, and then I'll go next. Let me share my screen.
Same
Yeah,
team
yeah,
member?
and I
Yes.
have the names on mine. Here.
Go ahead.
Do you want to write that down? Or you got it?
I got it. Thank you.
Okay, just making sure. Okay, so our presentation is on ZenMap. ZenMap is just the general user interface for the Nmap scanner. I'm pretty sure everyone knows what Nmap is by now. It's just a network mapper. It's an open source tool. You use it for port scanning, operating system detection, host discovery. Now configuring this was not difficult at all. You just verify everything's up to date, and then you install Python GTK for the general user interface, and then you literally just type sudo apt install ZenMap. So really simple to install. And this is just the different settings you can use for the Nmap scan profile. So it's really nice. Instead of remembering all of the different commands that you have to type in with this, you can just literally go through all the different options you have and select them. So I liked that aspect about this a lot. This is the result of an Nmap scan. So right here, it shows, it's Linux, shows that there's one port open, all of the ports closed, gives you all of the stats on it. It shows, I have a few other scans that I did over here. And this is the result of scanning a server. I had a server from another class, so I decided to scan that. You can see, obviously, there's way more ports open. And then this is just another part of this. It's just a map of the connections between all of the hosts. And then oh, whoops, I stopped sharing. Give me 1 second, sorry. All right, so I gotta move that out of the way. Okay, now I'm just gonna demo it really fast, okay? Okay, so let's see here. So right here, you can do different profiles. There's a ton of built-in profiles. So an intent scan, bear with me 1 second. This just decided to go slow. Let's see here. So an intent scan, I added in a decoy scan, which I'll show in a second. You go up here to the profile, you can do edit selected profile. Right here, you can select a ton of different options. The reason, I know this is a simple thing and a simple demonstration, but the reason why I like it a lot is because it's good for learning. I'm not a Nmap expert. I'm not an expert in any of this stuff. I'm obviously learning, and I think this is a great learning tool. Instead of looking up all these different commands, you have everything laid out in front of you. So just for the sake of learning, I really like this tool. You can do different target options. You can exclude certain, hosts if you don't want to scan them. The source, you can do a decoy to hide the identity. So I did a few different scans, one just on a normal host, and then I obviously scanned the servers. Right here shows all the different ports that are open. Let's see here. And then right here, another cool thing, if you click the legend icon, it shows what all of these, different colors and shapes obviously mean. So I really like that too. Let's see here. And now, bear with me 1 minute. I believe this is the decoy scan that I did. There was one decoy scan that I did. I just want to show what it looked like on the other side. I put in the IP address as 1234 instead, and you could see obviously that it worked right here. So I just wanted to show that example as well. That basically, you can just customize all of your scans, and I think it's a really great learning tool. And that's my presentation.
All right, great. Guys, do you have any questions for this group?
When you randomized the IP address, did you end up randomizing the MAC address that it was coming from too?
No, I didn't even look. There's so many different options, honestly. I didn't even look to see if that was an option. I'm positive that it is. Yeah, I didn't look to check if that was an option, but no, I don't think it did.
Would Nmap be an alternative to Wireshark?
No, I mean, I don't really think so. Honestly, I like this a lot better than any other tools. I think it's laid out better just for the sake of learning. I mean, I think this is great. Obviously, like I said, I'm not an expert, I'm learning, and this is gonna help me learn a lot. I encourage everyone else to use it as well. Yeah.
Nmap is a port scanner comparatively to Nmap. I mean, Wireshark, that is
Yeah, well, yeah, Wireshark's obviously, you know, like just checking, you know, the networks. Nmap is specifically scanning to see if ports are open.
Yeah, I just asked because like this GUI kind of looked the same, and you're targeting an address, and yeah, you got the.
Yeah.
I guess
this is the other
Wireshark's
part
more
of it.
all-encompassing. Yeah.
Wireshark's an
Yeah.
analyzer compared to an actual scanner.
Yeah.
Yeah.
Not actively sending packets, it's just scanning the packets coming through it.
Yes. Yes.
All right, great questions. Anyone else?
All right,
All
everybody.
right, great.
We would like to go next.
Okay, yeah,
All right.
shoot, sure. Go. All right, so next group then. Again, just give me the names of your teammates and you can get started.
All right, here are the names of our teammates here. Just make sure I have the first up.
Can you just confirm your last name so in case there's people named the same?
My last name is Philip Zilke.
Alex Harris.
And Jose.
Where's Jose? Is he not in the class today? Everyone should be here for the presentations, especially if they're presenting.
Oh no, he's here. He is in Discord, so yeah. Give a second. He's unmuting.
Yeah, I'm sorry about that.
Okay. All right.
What's
What's your last name, sorry?
My last name is Rodriguez.
All right, guys, please go ahead and
So,
get started.
in this project, we're doing project B first, that we went over type 1 hypervisors for system administration. So if anyone is not familiar with the type 1 hypervisor, it's pretty much just a VM host machine on bare hardware. Some of the benefits of a type 1 hypervisor, especially for a system administrator, is it's all to itself, usually in a web UI. Main examples of a hypervisor is EXI. Windows technically has hypervisor V, which can run on bare metal. And now, within the past year, Docker has actually put out their own type 1 hypervisor. It can help a system administrator mainly because of all the system hosts are in one central location, just giving off RAM usage. You can do virtualized networks completely and securing those networks, and it makes it more efficient and insight into the network, either through bandwidth into that network or downtime or just restarting and snapshotting VMs. Some of the main benefits are hardware diagnostics. If you're running it on bare metal, it can give off a lot of good information. The VMs within inter-network connections in regards to virtual ports. It makes it a lot easier for firewalls, logging especially, and a lot better for remote access and control, and the ability in itself to have more than one point of system failure. It also has, as I mentioned, a lot more security options. You can create your own DMZ, secure your mail server a lot easier, and a lot of other security options. Snapshots are, if anyone has been in these, this class even alone, you've used VMs and you should be snapshotting your systems occasionally in case you make a mistake on configuring our network, or just you need to go back and you deleted a file. Snapshots make it almost is a miracle for system administrators. So let's say you have a ransomware attack, your whole system gets wiped. You have an offline backup, a snapshot of all your VMs from a day ago. Within 10 minutes, you could have all those VMs running up from that snapshot. On top of that, backups, you can just back up the whole VM. So if you have network drives or even a VM that has is hosting your NAS, for example, TrueNAS could be run on a VM, which supports all different types of file systems. From example, from ZFS, which is more of a modern one, back to standard Linux and Windows. Also, it integrates really well with a lot of aftermarket storage, such as QSnaps or Synology network attached storages, which is the ability to pretty much partition out as much hard drive space, solid state, cloud platforms as you want to the VMs or the hypervisor itself. Some of the downsides of a type 1 hypervisor would be cost. Licensing is per processor, and now it's actually going down to per 64 cores just because of the modern day architecture of how insane servers are getting. Some servers can have 256 cores in a single actual physical machine. The ability, though, for larger companies to run that amount of infrastructure on a single machine makes it a lot more cost effective in the long run when you're looking at licensing. And it's not just limited to one machine. It can be clustered pretty easily. Some of the downsides for using a type 1 hypervisor, they're still finding vulnerabilities. Hackers want to take them over because most major networks, governments, companies will use this architecture and virtualize pretty much everything they own. AWS, any cloud platform uses some type of virtualization. They just don't throw bare metal servers up for people to use. So here's an example of the UI for ESXi, and which I will be demoing here in a second. If you have any questions. And here is the hypervisor UI. As you can see in this slide, it is using my main desktop, but it has the option just in the manager to connect to other desktops within the networking environment. So let me go out really quick and just show an example, our presentation of ESXi. This is the management port. So it's obviously, we had issues. I have too new of a CPU on my desktop, so this is hosted off my laptop through my network. But you can see that this is built out from my laptop and it's been running. You can see all the architecture and all the system hardware, give it 18 gigs of RAM. It has my CPU fully disclosed. Here is a performance review of just the CPU usage alone. And we can see a recent performance logs of all the VMs I've been messing with. I have a Ubuntu VM up, as you can see right here, which you can console into directly from this. Obviously, you can also SSH remote into it through the network. And you can give these a lot more secure connections. The internal it does have a lot of internal firewall rules just for the virtualization. And as you can see, it gives the MAC addresses, not the IPv4s, but we'll give the hardware MAC addresses, which is still very beneficial to a system administrator. Also, it has its own internal firewall for its ports, so you can just turn those off. And it has a lot of other nice physical access logging that wouldn't usually be accessible through a single device. As you can see, we have the data storage here, and we can browse even. So we have the VMs I've created, Parrot, Graylog, them, and then I actually have copies of the ISOs just to create another VM right off that. We have an event log, which logs pretty much everything we've done. We can add more adapters, virtual or otherwise. So if you have 20 different USB ports, Ethernet ports, you can use it on different interfaces and interface all those out into separate, firewalls or LANs or VLANs. So, and then we have obviously system performance, how much CPU, memory, and storage it's using, and it's all flexible. A main benefit of a Type 1 is you can, with a non-paid version, you can just throw system resources out without rebooting it. With a paid version of the licenses, which all Purdue students do have access to, a premium pro version of ESXi, if you want to play around on your laptop or computer, will let you do a live migration of the VM while it's running and snapshot. There are a lot of, yeah, pretty much it. Any questions?
Guys, do you have any questions for this group?
So
All right. So you just had one. Oh, there's a question. Okay. You just had one virtual VM there that you
Yeah,
started?
this is hosted on my laptop, and I had more started up. I had Graylog, and as you can see here, it's just I haven't messed with it much. I did a PF Sense box just to play with it, but it screwed up the routing table, so I deleted it. But I can, if you need to see, I can. This is nested within my other laptop through virtualization, and this is a Graylog server running just to do logs.
Okay. All right. So are you guys ready to do your
Yes, we are.
presentation? All right. Go ahead.
Hi, hello. My name is Alex Harris, and I'll be presenting Hadoop. Next slide. So just to go off of what Hadoop is mostly just going to be a cluster system where it comes to one actual machine is going to be hosting many other machines if you are to host it in a multi-cluster rather than a single cluster. Next one. Mostly a lot of times Hadoop is a very large portion of the importance. So you're having the actual storage capacity across an actual server itself with a master machine and the subsequent actual secondary machines, or as they would be called in the actual servers, would be slaves. It's relatively performance-wise nice to use. It's easy to actually set up your directories to be able to work with it. Next slide. So when it comes to the actual module itself, there's all Java based when it comes to Hadoop. When you're actually downloading the actual streaming services from itself and using the HDFS, also known as Hadoop Distributed File System, or shortened, it would be Hadoop File System, or FS. You'll be using that to transfer files and move them across the actual network. Next slide, please. And then you have your actual more so of your XML pages. You're setting up like the yarn and the mapreduce actual XML pages that we were tasked to set up to properly work with the server itself. Next slide. So, this is just one screenshot of showing that the actual file system is up and running, and you can see the actual files are running properly on the Hadoop server. And then you can see here the part the part 00005 actual system here with the 2 books already nested inside my downloads folder that was put into the network itself, which I will be demonstrating here in a minute. And then you have your nodes, which are set up. The top one running the actual 4 nodes necessary, as well as the secondary nodes being ran of the data nodes, with JPS being the command to run the nodes itself and be able to see that running. And then you have the master server itself running. You can see it's actually connected to the port necessary. And then you have the multi-cluster itself, showing that we have 3 servers running itself, which I will be demonstrating here in a second, showing that they are still currently running. MapReduce pretty much going apart. It's taking apart the actual files we have here and is reading them through and then separating them for the actual repetition of the files that we put through here. And we can see through the actual job written through, we have an actual output to read of it, which was the part 0000 file that I had downloaded from my server. All right, and I will then start sharing my screen. So the very first screen I'm going to show is going to be the master server itself. You're able to see the actual part file here, as well as the actual command files here being run through with the jar file running through itself till we have a streaming complete going right down here. And we see that there is no errors being run through with JPS being ran through as well. And we can see that the files are located on the Gutenberg new which HT user. And we're coming to see the multi-nodes set up for the multi-cluster. We can see that they're all still running properly. Any questions?
Guys, do you have any questions for this group?
No questions.
All right, great job. Thank you. Do we have a next
Yeah,
group?
my group wants to go next. All right. All right, Eric, you ready?
Yep. One sec. All right, so I'm Eric Garati. I'll be demonstrating Hadoop. So as you can see, right now I'm on my primary machine, but I have 2 secondary machines.
Can you hear me? Can you just give me the names of your team?
Oh, sorry. Then it's me, Tyler, Eric Karate, and John Sorensen.
Hold on. Eric Garati, you said?
Yep.
John Sorensen and Tyler
Yes.
Lappin?
Yeah.
Okay. All right. So go ahead, guys.
Yep. So as you can see, I started the distributed file system in the resource manager already. And so we'll run JPS to make sure that everything's running. We'll go to the secondary machines and run JPS, verify that the data node no manager is running. Yep. So we'll go back to the primary and we can go into the UI. This is Yarn. If we go into the HDFS UI, let's see, you can see that it has 2 live nodes, which are the secondary machines. So if we run this command, let's see. So we're going to take, let's see, book 1 and put it into output 1. All right, and it has the output. So if we check in the UI, we can see output 1. And we can see that it successfully did the word count. So we can do it for our second file too. So we'll name it output 2 and use book 2. And there we go. And you can see that it did the word count for the second book. Yep, that's it.
Nice job. Nice job. Really, to the point, right? Okay. Do you guys have any questions for this group? Okay, it doesn't sound like, I mean, it's great job. So I thought it was good. Now, are you guys ready for your second project?
Yeah, Tyler, you ready?
Yeah, give me 6 here.
All right, go ahead whenever. The same group, right?
Right.
Yes.
Sorry about that. I forgot to unmute myself. You guys see my screen?
No.
Oh, that's really. Oh, that's why. How about now?
Yeah, we can see it now.
All right. All right. So for this project, we're we're gonna like use like AutoStar daemon to run a Minecraft server. So why are we doing this? Because like Minecraft's is a multiplayer game. There's plenty of them out there, but it's kind of unique in the fact that it's generally a lot more difficult to curate a Minecraft server compared to other games like maybe COD or Halo. And also not only that, but since it also gives us like real world system administration experience, as consider the fact that we need to like set up the server, host it, and we need to find a way to manage it. And we're going to use Linux as the operating system for the host of the server. The reason why is because for Linux, like we have the option of having no GUI interface, and it basically generally gives us more performance. If the host machine with hosting the server were to have a GUI interface, more resources would be put towards managing the GUI aspect, and which could possibly like affect the game's performance. And again, it also gives us like Linux generally gives you more control over operating a server than maybe what Windows or Apple's operating services would. To set it up, we decided to use like Debian, which is just again like another form of Linux, more specifically 10.90, which again like no GUI. As you can see here, we unclick the desktop environment, which would set up the GUI, and we also need to make a SSH server. The reason why we need a SSH server because SSH is how we're able to access the server from outside machine, and we use PuTTY here as the interface. So we will enter like the IP address of the machine hosting the Minecraft server, and we used port 22 as the default. And after that, after we access the server through PuTTY and SSH, we use this command here to install to install and download the Minecraft server. And then we're gonna need to install Java because mainly because like the version of Minecraft we're running is basically Java edition, and so I'm pretty sure you need Java to manage that. So and then at the bottom screen here shows like we need to it's how we basically get the server to start running. As you see here, like as you see the XMX 2048, that's basically specifying that the max data to run it on would be essentially like over 2,000 megabytes, which will obviously translate into 2 gigabytes. That's because like the current machine we're specifically running on, its maximum memory is around like 2 gigabytes. So we need to like make sure this is just like insurance to make sure that server doesn't go over that limit, more or less. After you starting the server, starting the server, we just simply won't do it because mainly because like you have your host machine. Like if you just like if you're running it on like a local network, only people within that network can access it. So we need to so what we really did here is to basically configure the router to basically allow other people from outside your local network to join the server. And then one last things we do is we start like the daemon, which essentially manages the server for us. In here, within the file itself, under service, we essentially kind of configure it to where like the daemon only really we configure it to where only the daemon can manage the Minecraft server itself and none of the other files because we don't want it to like tamper with something on the machine. And so again, like it starts the server for us. And the last thing we do is like we basically enable the server. So what it basically does, it just more or less like starts or turns off the server, and it basically notifies the daemon whether it's on and off. If the daemon knows it's on, it'll start managing the server. If it's off, it'll obviously will deactivate until we otherwise say so. You guys got any questions before we continue?
Okay, so go ahead and stop sharing your screen, and then I will share mine where we have the actual project. It's on the screen. So basically, just really quick, this is the IP address, the local IP address for it, since it's running off of a secondary system that I have running. Basically, I can use the local IP. This is me logging in, and then I use IP addr in order to obtain the IP address. This is just to show you guys that it is indeed running off of the server. And so if I wanted to, I could just join into the server. That will load up here in just a second. And then if you look over here at the at this screen down here at the bottom on the right, this is the actual daemon that basically just makes sure that the server is always running. So if the computer were to crash or anything like that, when the server starts back up, then it will indeed allow the server to start automatically. So just really quick to demonstrate, I'm actually going to force the server to restart. And as you can see, it closed the server and all of the PuTTY interfaces closed down. But if I just wait here a second, the server will come back online on its own. Just got to wait for the server to come fully back on. Then it will boot back and be able to load the server again. That means it's almost done. Means I should just be able to connect to it here in just a second. Yep, see it right there, and we're back in the server. All right, and that's about it. Does anyone have any questions?
Any questions, guys, for this group? So it's you have to download the client to your computer, correct? And then you start it and you connect to the server via the port.
Yeah, so yeah, we have on the router, I have a open port running, and then people just use my broadcasted IP address for the router with the port to connect to it.
This is a multiplayer type of a game.
Yes, it's multiplayer setup, and then we have a daemon running to keep the server up and running.
So everyone uses the same port. They just come in and authenticate through it.
Yeah.
All right, great. I think there's something called Real Engine. I think that's the latest. All right, great. Good job. Guys, you know, good configuration there. Guys, do you have any questions for this group?
No questions for the group.
No questions. All right, great job. All right, guys, let me take a 2-minute break. Who's gonna go next?
Alexander and Yamada will go next.
All right, guys, just set up. Give me 2 minutes. Let me stop the recording. All right, guys, so who is going next?
We already have our screen up. Siamara and Alexander Sermon.
Okay, just two?
Yeah, so we presented our project B on Tuesday, or I mean Monday.
Okay, so you have, so Alexander, Servan, Garcia, right?
Yeah, Siamara Garcia.
All right, so you're presenting the Hadoop part.
Correct.
Okay, go ahead, please.
So we have our multi-node Hadoop cluster right here. This is the master, and we have the two slaves. Let me log in, actually. Let's log in these. So it's already running on a master, and you could check with the JPS command. We have a name node and a secondary name node, and you can also check on the slaves. They're both running the data nodes right now. And that's just the verify. So let me run, and also I could check on the web user interface, where the data nodes. The two slaves are up and running right now. So to run the command, I go into the directory. I also have it saved right here. Then I run the jar file to a new file. And as you can see, it starts running perfectly. My VM's kind of going slow too right now. I actually think my VM froze. Oh no, there it is. That was weird. So it outputted the file into the Gutenberg output 3, and we could check right here.
So now we're going to be going to the Hadoop interface, go to the utilizer browser, to the file system, and then we'll click the Hadoop user to show the display of the output.
And then right here is, it saved it into Gutenberg output 3, which we told it to.
So it's saved to that file. And then you'll download the file to open it up into a, it'll just download it. And then right there, it shows all the words that are in that book.
So that's pretty straightforward. We had the Python scripts and mapper and reducer scripts too. I could show you those too. This is our mapper script. And then our reducer scripts right here. So everything worked out correctly. That's pretty much it.
All right, great. Any questions for this group? All right, great job. And you said you've presented the other topic, correct?
Yes.
All right, so who would like to go next?
Could Patricia and I go next?
Yes, all right. So just state, put your name somewhere and then go ahead and start.
All right, I'm gonna share my screen. Can everyone see my screen?
Yes.
Yes.
Can we present?
Yes, please, go ahead.
Okay, so I'm Patricia Dizan and my partner is Danielle Turner, and and for Project B, we did the Chef software. So what is Chef? Chef is an open source software developed for complex system automation, and it's used to deploy and manage servers or in the cloud. It's compatible with Mac OS, Windows, Ubuntu, and Linux, and its programming languages include Ruby and Erlang. Some terminology with Chef software include node, client, recipes, and cookbooks. A node is a managed machine. It executes configurations for the node when the client runs. The client is the authorized user. Recipes are the list of resources to be added in the node, and it's typically written in Ruby. The cookbook is the collection of recipes, and it's used to configure an application or a service. So how Chef works, and there's shown a picture of the Chef software. So Workstation is where configurations are developed and installed on local machines. The Chef server is the center of the setup of the Chef setup, where configuration files are uploaded, and nodes are managed by the Chef server and contains the client that sets communication between servers and nodes. Some major companies that use Chef software include Facebook, Airbnb, and Shopify. So the steps to install Chef, there's 5 steps: to download and install Chef DK on the workstation, make a cookbook and write the recipes, set up the server, link both the workstation and the server, and configuring the nodes. So here are the commands to install Chef. I've already obviously done it on my VM. You would have to update and then download the latest Chef package, the server, and then to reconfigure it. And to create a Chef user and organization, here are the commands. They're very long. The second one creates the user, and the third command creates the organization. And then here's to set up the Chef workstation, the commands to set all that up. And then I will demonstrate I'm going to demonstrate different cookbooks, how to show them and create new cookbooks, and to write a new recipe. Can everyone see that, my VM?
Yep. Or I see the
No, we cannot see your
slides.
Oh, okay. Hold on. All right, can everyone see that now?
Yeah.
Yes.
Yeah.
Okay. So to show the different cookbooks, you'd cd chef repo, which is repository, and then cookbooks, ls, and then you can see these are the different cookbooks. I just named them examples 1 to 4, and LampStack, that was also an example that I was just trying to configure. So cd example. And then you could see inside the cookbook the recipes, so cd recipes. And these are the 2, so far there are 2 recipes inside the example cookbook, the default and time zone. They're both written in Ruby, that's why the extension is .rb. So to create a new recipe, you would do sudo nano, and to create just a simple one, hello.rb. So you would do file, and so this first line will contain a file resource referring to the hello.txt file. And then the second line refers to the content inside the file. This is just a simple recipe. Obviously, there's many different more complex recipes, but just for simplicity, we're just going to keep it to welcome to chef, this recipe. And then you can see that the hello.rb recipe has been added into the cookbook. So to apply it, to test it, you do sudo chef apply hello.rb. And then you can see the message, welcome to chef, is on there. So that's it for project B.
All right, great job. Guys, do you have any questions for this group?
No questions.
So this is, configuration management, basically, updating files and things like that.
Yes, especially for complex like systems. This is a good way to do system automation.
Okay. Great job. Okay. So are you guys also presenting the other topic, Hadoop?
Yeah, I'm getting started for that right now. All right, so for the sake of time, I'm just gonna quickly go through this. I'm Danielle. Obviously, my partner was Patricia. So these are all the prerequisites for installing Hadoop, like getting the SSH and PDSH and all of that in there, Java. And then installing Hadoop, I got it from Mir's SonicNet because the demo one wasn't working for us. You unzip it and you get everything configured in all of the files. And then setting up the multi-node cluster, I have the master, slave 1, and slave 2. And then skip through this stuff. We copied everything into the slaves. And then got everything up and running for the yarn files and all of that. Skip through to the actual coding. So for the MapperPy program, this was what we had for the mapper and then testing it. And then for the reducer, this is what we had and testing it. And then we're gonna go ahead and open the actual thing. So this is the master. For the sake of time, I already started everything, made sure that everything's still up. And then on slave 1, we can confirm that everything's up here and everything is up on slave 2. And then just to double check, we're gonna go here and see that we have 2 active nodes. And here we can get the status on the nodes. And then I'm gonna go ahead and actually run everything. So this is gonna show us all of our book files in a second. Or it's not. All right, we're just gonna skip that part. I'm just gonna tell you that we have Alice in Wonderland and The Adventures of Sherlock Holmes for ours. And then I'm gonna have it output to a demo live folder. All right, so we saw earlier the 100% map, 100% reduce. Then I'm gonna go ahead and pull up the output file here. And then open the file in the system. So here we can see all of the words and how many times they came through. And then another way to check is to go here to utilities and browse the file system, going to user, HD user, and then the demo live output. And then we can come here and once again see all of these and see that it was available on those as well. Yeah, I think that's pretty much it.
Great job. Great job. Guys, do you have any questions for this group? No, no questions. All right, great, excellent. Do we have any groups left?
Yeah, my group.
Okay, all right. So guys, go ahead and put your names on the screen there and get started.
All right. All right, can you see my screen?
Yep.
All right. So we did our project on Samba. Samba is basically like a software package that would give you a network administration flexibility and privilege in terms of setup, configuration, and your choice of systems and equipment. It came out in 1991. It been providing secure and stable and fast file and print services for all the clients using Linux and Windows. Andrew Tregell, he developed it. He went to Australian National University. The name Samba came from him by running the Unix command grep. He was looking for words with S, M, and B in it in order and came up with Samba. How to install it? It's kind of easy. Sudo apt update, then do a sudo apt install Samba. Then it's going to ask you, do you want to continue and confirm it? Click yes. Then to make sure you got it on there, just type the command where it's Samba. Also listed a URL if anybody want to try it. What does Samba do? Serves a directory, trees, and printers to Linux, Unix, and Windows clients. Assists in network browsing, domain logins. It also is a good file share for Linux and Windows. What can it do? Main things that it can do is just act as an active directory domain controller and as a backup domain controller for Windows primary domain controller. The versions of it, there are 21 total versions. The first published one came out in 2003. The last one came out in March of 2021. Versions 4.11, 12, 13, and 14 are still usable. The older versions are all obsolete. And Samba TNG is a tiny server for Unix operation systems. Its main goal is to provide fast and portable command source file systems. Just like Samba, it also acts as a file and print server for that sys clients and most versions of Windows and Unix. Now my partner, Anthony, will show you how it works.
All right, so my setup is, here I'll see the VM.
Yep.
All right, so my setup is I got a server and a Ubuntu client and then a Windows client. They're just gonna share files from each other. Basically how to access it is you just go to File, Directory, connect to Server. And I already have it here, but it's basically SMB. And then the IP address. And then the folder that you would like to, what do I call it? Connect to. Connect. And the way that I set it up is anonymous users cannot access it. You have to be a registered user. And then power. And then connect. As of right now, there's nothing in here. I'm just gonna drag these two files in. And I'm gonna go over to my Ubuntu client, do the same thing, connect. I think I'm going for search. Register, password. And those two folders are now in here from my server one. I'm gonna do the same thing and drag these two files in. And then go over to my Windows and do the same thing. Windows is a little different. You have to go to the File Explorer. And in the directory, you have to enter just the IP and then the folder. And then you have to log in. What was it? And then all those are now there. And then same thing with this. I'm just going to drag these files in just to show that the user is connected. And I'm just going to take this out and this one out. And just show that the file is successfully transferred. Same with this guy. It's a roundabout way, but in order for this to refresh or show that the two folders I put from the Windows into here, you have to unmount it and then remount it so it refreshes. And same thing with these also, just show that those are openable. And the same thing with this one. All right, and then that is Samba.
Nice demo. Guys, do you have any questions for this group? You basically used it for file sharing in your network.
Yeah, just a simple example of file sharing. You can also do printer services also. We just did file just to keep it simple.
Very good. Very nice demo. Are you guys going to also do your the Hadoop demo?
For that, we were having trouble with it, so no, we won't be presenting that.
You won't? Okay. All right. Who is next? Was that the last group, guys?
I'll go.
Okay. So how many people do we still have left? Guys, who else is left?
Let's go to the layout here. As we can see, it's started. Go to the file system. Here's where the count will be displayed. Here's the input and output files. And these are the two books that I chose. Okay, let's travel away. Let me travel to the directory for the books. What just happened here?
Just hit Control C.
There we go. All right, let me start the word count now. So this is where it's going to be stored. I already have an output file, so I'm going to name it too. Let's hope it works. Really hope it works. Sometimes it's selective. It's going to take about like 30 seconds. There goes the mapping. Okay, now for the reduce. Hopefully it works. Yes, there we go. Thank God. All right, let me, excuse me, show the output for that. Okay, here we can see all the where it's counted. And that's pretty much it for that. Is there any questions?
Nice job, Acorn. Guys, do you have any questions on this part of the presentation? Nope.
What,
All right. Yeah, go ahead, please.
I was just gonna say, what book did you use?
The books, they were called Barbarossa, and I forgot the name of that book, but it had Vicious in the title.
Ah.
I can't find them because it just chose books randomly. All right, now I'm gonna do my topic. Let's see. All right, so for my topic, I chose Webmin. And Webmin is a web-based interface for system administration in Unix. Some of the many things you can do with it is adding and removing users, changing passwords, installing or updating software packages, set up a firewall, manage the space on a drive used by all the users, and really a lot of other stuff that would take too long to mention. These are just some of the features that stood out to me. It basically removes the need to work from the terminal in a lot of cases such as these. And this is a picture of the interface. You can get a better look of it once I demo it. The installation is pretty simple. First thing we need to do is download the repository keys using these commands. And the repository keys are basically used to verify that you're downloading the package from the correct source. Then we install Webmin itself using the following command. Once it's finished installing, we can check the status of it using this command. We'll get to that in a second. Next, we have to allow the required ports for it, then reload the firewall to make sure the changes take place. To access the interface, we take the IP of our VM and then the port number, and then we log in with the current VM user details. Let's go ahead and check it out. I'm pretty sure I'm already logged into it, so go ahead and log out real quick just to showcase that. So new user, Tor. Just let load back up. All right, so here we have the Webmin interface. And here we can see a lot of general system information, such as the host name, processor info, memory usage, storage usage, package updates, a lot of other stuff. It's pretty informative. Here we can see some graphs for the stats from like the last 10 minutes. Then down here we have the recent logins, network interfaces, and disk usage. Let's go to the system here. Here I'm gonna showcase the adding and removing of users. Let's see. So here we have all the users on the system. And for example, we have the Hadoop user I just demoed. Then we have the new user, which is me. Let's go ahead and create a new user. So here we have all the information that would pop up when doing it from the terminal, plus other stuff. So let's see, test user, just for example. Here we have the test user here. Let's check that terminal. Go back to the home directory. Here we can see the test user. Now let's, oh wait. Now let's remove the user. Delete. Let's go back. We can see it was deleted. To confirm that. Oh wait, it's not deleted. Oh wait, maybe I gotta refresh the terminal. Pretty sure that worked just a second ago. It says it's gone from here. I'm not sure why it's, oh, that's what happened. That's what happened. I did not delete the directories for it. Whoops. Let me see, since it would take too long for me to go through all the directories, I'm gonna do that again. Let's go back and delete it. Yeah, I clicked on delete user instead of this one, so that's why I didn't. Yep. Last time I put test user 2 and now it's gone. All right, so for the software packages, go to this. And here we can see where we can manage the packages or the applications. We can see the installed packages and also install new packages. So for example, Firefox. Here it has all the packages for Firefox here. Another example here, we can update all the packages that need to be updated. I won't do that just to save time. For the firewall, let's see. Here we can set rules for the firewall. Yeah, that's it really. There's a lot of different things that you can do with it, but it would take, like I said, it would take a long time to explain all that. And like I said, those were the features that stood out to me. And that's it. Is there any questions?
All right, great job, Laquan. Great job. Guys, do you have any questions for him?
Questions?
All right, great. Excellent conclusion to a sysadmin. Pretty good. Thank you very much. So I think he was the last group. What? So I just want to double check because let me stop the recording.